There are a few special cases with binomial multiplication that you're going to want to know offhand. The first one is called the perfect square. The perfect square is when you have two binomials that are exactly the same and you're multiplying them by each other. And the reason it's called the perfect square is because we could theoretically rewrite this expression as x plus 2 squared. When we do the FOIL on this binomial multiplication, we end up with x squared plus 2x plus 2x plus 4. When we finish that, we get x squared plus 4x plus 4. Every perfect square trinomial like this is going to have two features. The b is going to be 2 times whatever these values are. So 2 times 2 in this case. And the c is going to be this value squared. So 2 to the second power. So let me show you a separate example. Let's talk about x plus 5 times x plus 5. When we FOIL this out, we're going to get x squared plus 10x plus 25. Notice how 10 is just 2 times 5, and 25 is just 5 squared. That's going to be true for all perfect square trinomials, which are the result of squaring some binomial like this. And remember, we call this perfect square because we could write it as x plus 5 squared. The other case you need to know about is what we call difference of two squares. And we call it difference of squares because of how the product results, like what the end product is. But here's what it looks like in general case. X minus 3 times x plus 3. It looks a lot like the perfect square scenario, except in this case, one is addition and one is subtraction. When we FOIL these, we end up with x squared minus 3x plus 3x minus 9. The reason this is a unique case is because what's happening here in the middle. Here in the middle, you end up with opposite terms, 3x and negative 3x. They'll cancel out. So when we simplify this thing, we end up with x squared minus 9. And notice what we have. X squared is a perfect square, 9 is a perfect square, and they're being subtracted. Therefore, we have the difference of two squares, meaning the subtraction of two perfect squares, x squared minus 9. Okay, notice that x is just x, this part of the binomial squared, and 9 is just this part of the binomial squared. With that in mind, if we were to look at the problem x minus 6 times x plus 6, we might anticipate that the final binomial is going to be x squared minus 36, squaring 6 and squaring x. And in fact, if we do FOIL, x times x is x squared, x times 6 is positive 6x, x times negative 6 is negative 6x, 6 times 6 is negative 36. Notice again, we've got this going on in the middle where we have these opposite terms that cancel out, and if we simplify, we do in fact get x squared minus 36. This is important to note because you're going to be asked to factor things in this difference of square form, and you're going to want to know pretty quickly, okay, it goes right back to something like this. Let's look at another example. Let's say we had x to the 6th power minus 144. And we were asked to factor this. Well, I notice right away that x to the 6th power is a perfect square and 144 is a perfect square. So by definition, this is the difference of squares. So I know my binomials are going to be the square root of x to the 6th power, which is x to the 3rd power, minus the square root of 144, which is 12, times the square root of x to the 6th power, which is x to the 3rd power, plus the square root of 144, which is 12. So it's once you know the pattern, it's very easy to factor difference of squares, because you just have to be able to take the square root of 144 and the square root of x to the 6 in this case. So that's how we factor difference of squares. So the two important products you want to remember from this section are the perfect square trinomial and the difference of squares.